Welcome to the Sat-Coord Beam Gain Contour Editing tutorial. In this tutorial I will show you how you can use Sat-Coord to create new custom gain contour diagrams from scratch, how you can use Sat-Coord to generate new contours using the ITU antenna pattern library, how you can edit existing GIMS gain contour diagrams, and how you can then export these diagrams into GIMS format files or databases. In order to view GIMS beam data inside Sat-Coord, you need to have the ITU GIMS software installed and functional on your machine. You can find out more information and download GIMS by visiting the relevant ITU website. A link is provided in the description below this video. The GIMS database is contained on the IFIC DVD and must be set up and operating within the ITU GIMS software before you can use Sat-Coord to view this data. So first I will click on the Tools menu item and then select Beam Plotter from the drop-down menu to open a new empty Beam Plotter tab. From here I will create a new dataset by clicking on the Add Dataset icon in the toolbar. Then I will add a new network by clicking on the Add Network icon in the toolbar. This will prompt us with a dialog asking for some information on the network we wish to add. I will specify the administration as the UK, change the network name to TestSat, and specify an orbital position of 60 degrees east and then click on OK. As soon as the network is added, you can see that the projection of the Earth centered on the orbital position of 60 degrees east. Next, I will add a new beam by clicking on the Add Beam icon in the toolbar. I will leave the beam as a downlink beam but change the name to Test. Now the new beam is added to the data tree. Next, I will add a new gain contour diagram into the newly constructed beam by clicking on the Add Copolar Gain Contour Diagram icon in the toolbar. So now we have a new empty gain contour diagram. In Sat-Coord, gain contour diagrams can be one of four types, which can be selected through clicking on the Gain Contour Diagram Type button on the toolbar. They can be of type Custom Data, which means they are a custom Sat-Coord type, which allows us full control over the gain contour diagram and is what we will be using in this tutorial. Secondly, they can be of type GIMS Data, which means that they reference a diagram in a GIMS database. If you import beam data from an SNS database, gain contour diagrams are set to this type by default and are retrieved from the GIMS reference database. Thirdly, they can be set to no data, which is the default state for newly added gain contour diagrams such as this one. Lastly, they can be set to simple data, which is a simple global gain contour with user-defined relative gain over the visible Earth. For this gain contour editing tutorial, we will set our gain contour diagram to custom data type. As soon as we choose the custom data type, you can see that the beam plot on the right hand side is now showing us an empty gain contour diagram with the blue outline showing us the visible Earth from this location. Gain contour diagrams are made up of boresights and gain contours. To generate a new gain contour diagram, we will need to add both of these. To add a boresight, select the Add Boresight button on the toolbar. Sat-Coord allows us to add a boresight by specifying a latitude and longitude or by capturing the boresight on the map. I'm going to select the Capture on the Map. Next I will click somewhere on the beam plot that I want the boresight to be located. As soon as I clicked on the map, you can see that a boresight had been added at the location I clicked. If we are not happy with this location, we can now drag the boresight to a new location. Alternatively, I can right click on the boresight for other options available, including the ability to edit data. This allows us to change the relative gain, the latitude and the longitude of the boresight. Alternatively, you can double click on the boresight to edit the data. Next, we need to add a new gain contour. To add a contour, select the Add Contour button on the toolbar. Sat-Coord allows us to add a new contour by elevation angle, by ITU region or by capturing on the map. Once again, I will choose to capture on the map. Once I select Capture on Map, I am prompted with the relative gain value to be associated with the contour, and I will specify 0 and click OK. Now we can begin to add the points that define the contour by clicking on the beam plot. Once I'm done, I will click on the Finish Adding Points icon in the beam plot toolbar. Now we have defined a new open gain contour. I can drag individual points around by selecting the point I wish to move and then dragging it to a new location. I can also add new points into the line by selecting a line segment and then choosing the Add Point icon in the toolbar, or alternatively by pressing the third mouse button or mouse wheel. I can also delete points by selecting a point and then pressing the Remove button on the toolbar. There are also a number of options available by right clicking on the contour. If the contour is open, I can choose to close it, or alternatively I can close it on the horizon. I can edit the relative gain associated with the contour. I can choose to add or remove points generally from the line. These options will maintain the shape of the contour, but either add or remove points on the line. I can also generate new contours from this one, more on that shortly. I will close the contour so that we have a properly defined gain contour, and I will add some extra points into the contour. Now let me show you how you can use Sat-Coord and the ITU antenna pattern library to generate new contours on the basis of our existing manually constructed contour. In order to use this functionality, you need to ensure you have the ITU software installed that defines the antenna pattern library. If I right-click on the contour and then select Generate Contours, this opens a new dialog. In this dialog, I first need to specify the contours I wish to be generated. You can only generate contours of relative gain lower than the base contour. In this case, I generated a contour with relative gain of 0, so it has by default filled in the contours to be generated as the -2, -4, -6, -10, -20 and -30 dB contours. The granularity defines how fine the points in the generated contours will be. The higher the granularity, the more accurate the result, but it increases the generation time. For this tutorial, I will leave it on medium. Next, I need to define the antenna pattern to be used from the ITU antenna pattern library from all of the space antennas that are available. For each pattern, there is a description of the pattern as well as some other fields which may need to be filled in to properly define the pattern. If the pattern is properly defined, then you can see a plot showing how the relative gain changes by off-axis angle. I can move the mouse over the antenna plot to see the exact relationship between relative gain and off-axis angle. So for example, we can see that at around 5 degrees off-axis, the relative gain is around -30 dB, and therefore the generated -30 dB contour will be around 5 degrees off-axis from the contour that we constructed. If you wish to have a different pattern, you can select it from the drop-down box, or you can change the parameters of the existing pattern by modifying the input values. For this pattern, we can change the beam width to alter how fast the beam rolls off. I'll set the beam width to a value of 2 and then click OK. Sat-Coord will now start generating the new contours for us. As you can see here, based on the contour I constructed, new -2, -4, -6, -10, -20 and -30 dB contour lines have been generated. You can also see that new contours have been generated both sides of the contour I constructed. I do not want the contours generated inside the contour I constructed, so we can remove those by selecting them and then pressing the Remove button on the toolbar, or by pressing the Delete key. Now I'm finished generating my gain contour diagram. There is a boresight and all of the required contours. Next, I want to show you how you can modify existing GIMS gain contour diagrams. To do this, I'm going to import some data into our beam plotter tab from an SNS database. To do this, I will click on the Browse menu item and then open the SOS database. I will start filtering the SOS data to just the information I wish to send to the beam plotter by performing the Notice Admin search and then the Notice Satellite Name search. I will then send information from a particular network to our beam plotter tab. As you can see, this data has been put into a new dataset in the left-hand pane of the beam plotter tab. If I first select the network I wish to view the beams in, this will change the view of the beam plot to the orbital location of this network. I can then select one of the gain contour diagrams which has been imported. If I click on the gain contour diagram type button on the toolbar, you can see that it is specified as a GIMS data type. If I select the GIMS settings option, it will open up a dialog giving me information on the GIMS database and the beam data it has selected from the GIMS database. It is possible to point this to a different beam in either this GIMS database or an alternate GIMS database if we wish. In this tutorial, I want to show you how you can edit data from an existing GIMS beam. To do this, I select the Import Data to Custom Diagram button in the toolbar. This will import the current GIMS data into custom data format and automatically change the type of the gain contour to custom data. Now that the data is in custom data format, we have all of the options available to us to edit the gain contour diagram. For example, I can select a contour and move points around, add points or remove points. If you are constructing gain contour diagram data for a new filing, when this is submitted to the ITU, it will need to be submitted in GIMS format, and so it must be converted into GIMS data. Also, please note that the gain interpolation algorithm that Sat-Coord uses for custom data is not always exactly the same as the gain interpolation algorithm that GIMS uses. and therefore if you are constructing gain contour diagrams in order to perform an analysis, it is recommended that you first convert the custom data into GIMS data. Let us go back to our generated contour and convert this into GIMS format. To do this, there are two options in Sat-Coord. First, you can export an individual diagram into GXT format. These GXT files can then be read by GIMS, so can be imported into GIMS and saved in a new GIMS database. Alternatively, you can, at the network or beam level, export all diagrams you have made into a new GIMS database. To do this, select the new beam that we made and then choose the Export to GIMS DB button on the toolbar. It prompts us for a database location and a name for the new GIMS database. Once that is specified, Sat-Coord will start the export process and open up a new dialog providing information on the export process. It is possible that the custom gain contour data that you generated could not be exported to GIMS format if there is some validation issue with the gain contour. For these cases, you will need to export a GXT file first and then import that into GIMS to understand what the validation problem with the contour is. For our case, the beam is exported successfully into a new GIMS database. If you need to export a diagram to GXT format, you can do this by selecting the gain contour you wish to export and then pressing the Export GXT button on the toolbar. Now we have generated the GIMS database, we can point our gain contour diagram to it. To do this, I need to change the diagram back to GIMS data by clicking on the Gain Contour Diagram Type toolbar button. Next, I click on the GIMS Settings button on the toolbar. I need to point the GIMS database to the new database that we just generated. Next, I need to choose the network name and then select the beam. A plot showing the gain contour diagram is provided at the bottom of the dialog for reference. If I click on OK, then the gain contour diagram will be pointing to the GIMS data in the database we generated. Thank you for watching. This ends the beam gain contour editing tutorial. If you have any questions, please contact us using the information in the description below.